Hello. In a previous video, we showed that if you have a stationary Markov chain and a recurrent state, then the probability that the chain will return to that recurrent state an infinite number of times is equal to 1. Let me refresh your memory. That was this result here. The chain certainly returns to J at least once, if and only if the chain certainly returns to J an infinite number of times. So I could say a recurrent state is infinitely recurrent. Now what about transient states? Now I know that for a transient state it's possible that the chain will never return to that state. But that doesn't mean that the chain might not sometimes return an infinite number of times. It's possible that the chain never returns sometimes and returns an infinite number of times sometimes. Now that's the question. Is it possible for a transient state to have an infinite number of returns? And we will answer that question in this video. Let's go back to the definition of transient state. Recall that a transient state satisfies the probability of Tj less than infinity is equal to 1, where Tj is the time for the chain starting in J to return to J. Tj is a random variable. So that means that the probability of return in a finite time is less than 1. Okay. It may never return. So consider a Markov chain with transient state J, and let Pj be the probability that the chain starting in J returns to J. Now this probability is less than 1, because that's what this says here. Now let's define Nij as the number of visits to J for a chain starting in I. All right, so I'm starting in I, I'm moving around the chain, and I visit J. Every time I visit J, I count it, so I'm going to count that. Now Nij could possibly be infinity. Now consider for each value m, so m is going to be a positive integer, I'm going to define an event Bij of m. So I is the starting state, J is the state that's visited, and m is another variable. Bij of m is equal to the event that Nij is greater than or equal to m. We can give an example of Bij of m. Let me just say, for instance, if I wanted to say Bij of 5. So Bij of 5 is the event that the chain starting in I visits J at least 5 times. At least 5 times. So you can generalize that, Bij of 20, Bij of 100, etc. Right, so have that concept in your mind. Using the conditional probability formula, we can show the following statement. The probability of this event, Bij m plus 1, is equal to the probability Bij of m times Pj. So in other words, the probability that the chain visits at least m plus 1 times is equal to the probability that the chain visits m times Pj. So I want you to prove this. The exercise goes as follows. Part A. Using a partition consisting of the event Bijm and its complement. So this is Bijm, the complement is everything else. So your partition has 2 sets. So using these 2 sets, prove this formula here. So you can read this hint, that may help you. Now, second part, use the first part to prove that Pij of m is equal to the mth power of Pj. Part C, using B above, show that the limit as m goes to infinity of the logarithm, and by log I mean the natural logarithm, that the logarithm of the probability of Bijm tends to minus infinity when m goes to infinity. Then take exponentials of both sides of this equation and show that the limit as m goes to infinity of Bijm is equal to 0. So why does this give us my result? Well, remember what we're trying to find. I'm trying to prove that the chain starting in I will always visit the transient state j a finite number of times. So let's consider this event C, which is the event that the number of visits to j from a chain starting in I is infinite. I want to show that C has probability 0 because I want to show that the chain will always return a finite number of times. Now what about this event C? This event C is contained in all these events Bij of M. So the probability of C must be smaller than the probability of all of these events. Now, since this probability becomes arbitrarily small, it follows that P of C is less than all positive numbers, so it must be 0. The probability of an infinite number of visits to a transient state starting in any other state will always be 0. So in summary, recurrent states, they always come back an infinite number of times. Transient states, they never come back an infinite number of times. They always come back a finite number of times. Okay, thanks for watching.